Okay. Hmm. So we have just completed the reflection of light. We have
Yeah, we
completed
told
the,
we'll do refraction today.
yeah, refraction of light. I will start today. So just a minute. Hello, Nabal.
Hello, sir.
Hello. Today I'm starting the refraction of light. So the introduction of the refraction of light uh, you studied in the class 10th chapter light. Okay, so refraction takes place when light is going from one medium to another medium. Refraction means a phenomena in which the bending of light will take place when the light will pass from one medium to another medium, and due to this refraction of light, various phenomena we can see. Okay, like you can just take a glass of water and dip the pencil in it. So the pencil will just will it will be looking to you like there is a bending in the pencil. Okay, uh, maybe you have seen this. So this is happening due to the refraction of light, and there are various phenomena like the twinkling of the stars. Twinkling of stars. We have the stars now in the sky. So stars are very far from us, very far from us. So there also we see the stars twinkles. But what happens actually? The light coming from the stars are getting refracted by the atmosphere. Okay, and due to that, sometimes we are getting more light and sometimes we are getting less light. So the intensity of the light from the star is changing due to the refraction. So there are various phenomena that are taking place due to the refraction of light. So first of all, the refraction of light is the bending of the light when the light travels from one medium to another medium. Medium means air is a medium, water is a medium, glass is a medium, oil is a medium. There are different medium. Okay. So we define two types of medium. So we say about the medium that when a light travels with low speed, comparatively low speed, there is a specific speed of light in air or vacuum. Speed of light is 3 into 10 to the power 8 meter per second in air, vacuum or free space. But what happens when the light travels in a rarer medium? When a light travels in a denser medium, the speed of the light becomes less than. So we define two types of mediums are there: uh, optically denser medium and optically rarer medium. So now, what is optically denser and what is optically rarer? So optically denser, you can say a medium in which the speed of light is comparatively less. Okay,
Slower.
slower. Or but the actual thing
The
about
refractive
the
index is low.
yeah, actual thing about the to decide which medium is denser, which medium is rarer, is decided by the refractive index. The medium for you at a time can be rarer also, and for other person that medium can be uh, denser also, depending the pair of medium we have. So uh, okay, so now refraction of light. So basically very simple phenomena. This is the interface and this is suppose medium 1. Medium 1 means just we can take any medium. Suppose this is the air here. This is the air. Hmm. So there is medium 1 and medium 2. And this is the interface. What is the meaning of the interface? Interface is separating the two medium. And this is the incident ray. This is incident ray. And this is the refracted ray. Okay. So this is the medium 1. Suppose this is the air. And suppose this is the medium 2 water. So you can just say that water is a denser medium here and air is a rarer medium. So there is a ray of light coming from air and entering to the water. And what I have told you, whenever the light ray changes the medium, bending of light will take place. So now you can say light here is coming from air and there is a bending of light. And if there is no change in the medium, then this is the exact, or not the exact, this is the path of the light without refraction. This is the path of ray or light ray, path of ray without refraction. And what is this? This is the refracted ray, or you can say this ray is getting bent. So you can say that this is the incident ray. Incident ray. This is refracted ray. Okay, and this is normal. Now you know, I think, what is normal. Making an angle of 90 degree with the interface or surface. So talking about the angle of incidence and angle of refraction. So this angle will be the angle of incidence. The angle between the, no one is asking what is angle of incidence, no, what is angle of refraction, but you should know. The angle between the normal and the incident ray is angle of incidence I, and this not necessarily you can take angle of incidence I. It can be theta also. You can take any angle. And angle of refraction is angle between the normal and the refracted ray. So now you can see there is a bending of light taking place. So this is basically the refraction of the light. Bending of light when it passes from one medium to another. Now I have told you two types of medium, denser medium and rarer medium. So we say optically denser medium. Uh, optically means with respect to light, you can say. So optically denser medium in which the light travels slower. Optically denser medium, optically rarer medium in which the light travels faster. This is decided by the refractive index. We will study the next topic. What is refractive index? And there is a term optical density. More will be the optical density of a medium. More will be the optical density of the medium. More will be the denser the medium is. And what decides that the optical density is more and less is decided by the refractive index. So refractive index is the measure of optical density. Refractive index is very important topic for the refraction of light. So refractive index, uh, very simple. Refractive index is basically the ratio of the speed of light in air divided by the speed of light in medium is the refractive index. So refractive index, simple. This is the refractive index. So refractive index is represented by mu. And what is the refractive index? C. C represents the speed of light in air, vacuum, okay, divided by the speed of light in medium, okay, for which this refractive index is. So this is the refractive index. So remember this formula first. What is refractive index? Okay. C is the speed of light in air. And we know speed of light in air is 3 into 10 to the power 8 meter per second. So value of C you can write C is equal to 3 into 10 to the power 8 meter per second. And this will be the V is the speed of light in any other medium like water, and refractive index will always be greater than 1. Why? Because this value will always be greater than this value, because this is the maximum speed of the light. Okay, this is the maximum speed of the light. Okay, maximum speed of light you can write. Maximum speed. In air or vacuum, the speed of light is greatest. Okay, there is one more thing. If the refractive index will increase, so if the refractive index will increase, what will happen? The velocity or speed of light will decrease. Refractive index will increase, the speed of light will decrease. So actually what is happening? If a light is going from rarer medium to denser medium, so what will happen? The speed of light will decrease when it will enter to the denser medium. So for the denser medium, the refractive index will be more. So that is why when the refractive index is increasing, speed of light will decrease. Refractive index of air is equal to 1. Remember this value. Refractive index of air you will take 1. Why 1? Because from this formula, refractive index of air is equal to C divided by, again you will put here the C. Okay. Okay. This is one example. If it is written somewhere, refractive index of any material is this. For example, refractive index of diamond. Diamond medium is 2.4. So what is the meaning of this statement? So they are saying refractive index I will represent with mu, remember. So refractive index of diamond, okay, this is the represent D. Refractive index of diamond is given as 2.4. Okay, so what does it mean? What is the meaning of the refractive index of any medium? This is equal to mu D is equal to C divided by speed of light in diamond is equal to 2.4. So you can write speed of light in diamond is equal to 1 upon 2.4 times of speed of light in air. So the refractive index 2.4 of any medium represent that in that medium, you can say the speed of light is 1 upon that refractive index time of the speed of light in air or a vacuum. Okay. Now we will see how the light will bend when it will move from denser medium to rarer medium or rarer medium to denser medium. For example, this is the normal, this is the interface between the two medium. And this is the incident ray, and this incident ray is coming from rarer medium. And this medium have the refractive index mu1. And this light is entering to the denser medium, and this denser medium suppose have the refractive index mu2. So obviously mu2 will be greater than mu1. Obviously mu2 will be greater than mu1 because this is denser, this is rarer medium, and this is normal, and this is the interface. So in this case na, light will bend towards the normal. So remember this point, light will bend towards the normal. Light will bend towards the normal. So light will bend towards normal. Light will bend towards the normal. Or you can say that the angle of incidence will be greater than the angle of refraction. This will be the angle of incidence, this will be the angle of refraction. So here you can say that I will be greater than R. Another point means, what will happen when the light ray is traveling from denser to rarer? This is the case. Here is the light ray. This is the light ray. This light ray is coming from a rarer, denser medium. Denser medium, and this denser medium have the refractive index, suppose mu1, and here the light is entering in rarer medium, and this rarer medium suppose has the refractive index mu2, and this is normal, and this is the interface. So remember, whenever the light ray is traveling from denser medium to rarer medium, it will bend away from the normal. This is the normal, so it will bend away from the normal like this. So this will be the, this should be the path of the actual path, means the path of the light when there is no refraction of the light. But what will happen now? This will bend away from the normal like this. So like this, okay? So this will be the path of the light when there is no refraction. Okay, so here also you can see light is coming. This is the incident ray coming like this. So actual the path of the light ray you can show without refraction will be like this. But actually the light is bending towards the normal. So what will happen here? This is the actual path of the light, or you can say refracted ray. Okay, so here which mu1 will be greater or mu2 will be greater? Matthew, mu1 will be greater or mu2 will be greater?
The refractive index, sir?
Yeah, means this is the denser medium. This have the refractive index mu1. This is the rarer medium. This have the refractive index
Yeah,
mu2.
new one will have more refractive index.
Yeah, so mu1 will be greater than mu2. So remember, the denser medium will have the more refractive index with respect to the rarer medium. Okay. After that, we will see there are two cases in which there is no bending of light. There are two cases in which there is no bending of light if the medium is changing also. Case when light does not bend. You can, this is a normal, this, and here is some medium. Okay, here is some medium and here is another medium. So a light ray the is incident normally. So this is the normal incidence of the light like this. So light will pass straight. See, this is the interface here between two media. So when there is a normal incidence, there is no bending of light. This can be explained by the wave theory of the light, but I am not going in that why this is happening. So you have to remember, when there is a normal incidence, so light passes straight. Okay, even the medium is changing here. So this is known as the normal incidence. Why we are saying normal incidence? Because light is traveling along the normal. Fourth, if this condition is given, a light ray is passed like this and this light ray passes straight. And we have two medium. One medium have the refractive index mu1 and another medium have the refractive index mu2. Then here what will happen? The medium can be different, but mu1 is equal to mu2. If the light is passing straight, if this is a oblique incidence, not the normal. For the normal incident, the light is passing straight, but not for the oblique incident. For the oblique incident, there must always be the bending of light until and unless the refractive index should be same in which the light is traveling. So here the light is traveling, light is passed straight. It means that the refractive index mu1 must be equal to refractive index mu2, or it can be the light here can be moving in the same medium, you can say. Okay, all of you, take the screenshots, please. And arrange the screenshots in a proper order.
Done, sir.
Okay.
Yes.
Okay.
Done, sir.
Okay. Nafisa and Nawal.
Yes,
Done?
sir. Yes, sir.
Okay.
Done, sir. Hmm. Done, all of you? Yes, sir.
Hmm. Now we will move to very important relationship. The relationship between the speed of the light and the refractive index and wavelength of the light. So light is a electromagnetic wave we have just No. Light is a wave. So for a wave, there is a relation between the speed of the wave, frequency of the wave, and the wavelength of the wave. So V is representing speed of the wave in some medium. In medium, wave can travel in any medium. It can travel in water, can travel in air also. So we have to define the medium in which the wave is traveling. Wavelength of the wave in medium and frequency of wave in medium. So this information you should know for a wave. Light is also a wave. So light will also follow this equation. Okay. Now here, for example, suppose the light is traveling from rarer medium to denser medium, and this is the normal. This is the I is the angle of incidence, R is the angle of refraction, and in this medium, what is V1 here? V1 is the speed of light in medium 1, and V2 is the speed of light in medium 2. Speed of this light ray in medium 1 is V1. Speed of light in this medium 2 or denser medium is, suppose this is the rarer medium and this is the medium 1. Okay, and this is medium 2. Medium 2. So mu1 is the refractive index of this medium 1, and mu2 is the refractive index of medium 2. Okay. And mu2 is greater than mu1 because this is denser and this is rarer. So I am writing what is V1 and what is V2. So V1 is the speed of light ray. You can say light. You can say light ray or you can say light. Speed of light in medium 1. And medium 1 is a rarer medium. And mu1 is the refractive index of medium 1. Now you have understood, I think you can now clearly understood that what will be V2 and what will be mu2. Okay. We know that refractive index increases, the speed of light will decrease. Refractive index increases, the speed of light will decrease. For example, you can take one example. If the light is traveling from air to water, so in water the speed of the light is less. And in terms of the refractive index, you can say if the water have the refractive index more as compared to air, so you can say that refractive index is inversely proportional to the speed of the light. Refractive index is inversely proportional to the speed of the light. So this relation should be valid here. You can write refractive index. Ri means the refractive index of medium. Refractive index of medium is inversely proportional to the speed of light in that medium. Speed of light in that medium. Okay. So we can say V is the speed of the light, okay, in medium. So V is the speed of light in medium. This is inversely proportional to the this relation. So with the help of this relation, we can just drive the relation between V1 and V2 and mu1 and mu2. So if you will write mu2 divided by mu1. So as the speed is inversely proportional to mu, so V1 by V2 can be written as means mu2 by mu1 will be written as V1 by V2. Okay. Okay. Now there is one more thing here. V1. What is V1? V1 is the speed of light in medium 1. Speed of light in medium 1. And V1 can be written as, from this formula, F1 into lambda 1. V1 can be written as F1 into lambda 1, and V2 can be written as F2 can be lambda 2. And there is one more point, and that point is very, very important point. During the refraction, speed means when the light crosses one medium to another, when light goes from one medium to another medium, speed of the light changes. Wavelength of the light will also change, but frequency of the light will remain same. Why? I will tell you. So remember this point. Frequency of light will not change during refraction. During refraction, as the frequency depends on the source of light. Source of light. What is the meaning of the frequency? Frequency is basically the number of waves in 1 second. And that number of waves in 1 second is only depending upon the source of the light. What types of source is there? Now here the light is coming from only one source. There are no other sources. This light can be the light for this light ray can be from any object, can be from me also, can be from uh, this bulb, can be from the sun also. So source is same, so frequency remains same. So that is why during the refraction or when the light changes the medium, frequency remains same. So F1 is the frequency in this medium and F2 is the frequency in this medium, and there is one more term. I want to write lambda 1 here, and here is the lambda 2. Okay, and here is the frequency F, and here will be the frequency F. Because the frequency is not changing, so you can write frequency in medium 1 is equal to frequency in medium 2, and that can be written as F. So V1 can be written as F lambda 1, and V2 can be written as F lambda 2. Now you can write V1 by V2. Now you can just find the ratio of V1 by V2. When you will find V1 by V2, this F and F will be cancelled out. So you can write it as F into lambda 1 divided by F into lambda 2. F and F cancel out. So V1 by V2 can be written as lambda by lambda 2. So finally we will have the relation. Very important relation. Very important. Refractive index mu2 means refractive index of medium second divided by the refractive index of medium 1 is equal to speed of light in medium 1 divided by the speed of light in medium 2 is equal to lambda 1 by lambda 2. Means the wavelength of the light in medium 1 divided by the wavelength of the light in medium 2. So remember this formula. This will be helpful for you. Okay, so this is the relation between frequency, wavelength, speed, refractive index, and there is one more term. There is one more term here that I want to discuss. If it is written that mu2 divided by mu1, if it is written that, then this can be written as mu2 here and 1 here. And what does this mean? This means the refractive index of medium 2 Refractive index, if it is written like this, see, this can be written like this, and this can be said refractive index of medium 2 with respect to medium 1. Refractive index of medium 2 with respect to medium 1. Okay. Refractive index of medium 2 with respect to medium 1. Another thing, if it is given that refractive index of any medium, that is only mu is given, that is given as 2.4. So always remember that if only the refractive index given is like this, refractive index of medium is 2.4, always that refractive index will be with respect to air. Okay, with respect to air. For example, this is the refractive index of diamond. Okay, refractive index of medium diamond. So how you can write this thing? Refractive index of diamond with respect to air is equal to 2.4. Basically, we define refractive index in two ways: absolute refractive index and the relative refractive index. Absolute refractive index with respect to air, if you are measuring the refractive index, that is known as the absolute. With respect to any other medium other than air, the refractive index you will measure
Relative.
will be relative. So I am not going in that because that is not the important part, but at least this thing, if you know, it will be okay. Ultimately, no one is going to ask what is the relative reflective index. They will ask you the question in the exam. So these things you should know, means how to write. Okay, so now how can you write this value? If it is written that mu d and a, d on the right side, a on the left side, so you can write in terms of the absolute refractive index, mu of d divided by mu of a is equal to 2.4. This will be used in the numericals. Okay, so after that we will solve one question. Very easy question I have taken. Okay, so this is the BW means speed of light in water. W here is representing water and V is representing speed, and G here is representing glass. So they are saying speed of light in water is this, speed of light in glass is this, and they are saying that calculate refractive index of water, refractive index of glass, and here they are saying refractive index of glass with respect to water. What is this? This is the absolute refractive index. Absolute refractive index means refractive index with respect to air, with respect to air. So we know that there is no requirement to write. We know what is the mu w, refractive index of any medium. Refractive index of any medium is equal to speed of light in air divided by speed of light in that medium. So C is 3 into 10 to the power 8. BW is 2.25 into 10 to the power 8. 10 to the power 8, 10 to the power 8 will be cancel out. So here you will have 300 divided by 225, and when you will cancel out, I think you will get 4 by 3. When you will cancel out, so you can cancel out with with 5. So 5 6 okay. So it will become 5 4 the. Now you can just cancel out with 5 again. So it will become 12. It will become 9. Now you will cancel out it with 4. So 4 3s are 12, and uh, you will cancel out with it 3. So 3 4s are 12 and 3 3s are 9. So 4 by 3 you will get. And further, if you want to solve it, then you can also solve it. Okay, so it will, when you will divide it, it will become 3 ones are 3, and 1.33, I think. 33 you will, 3333 you will get. Second, they are asking the refractive index of glass. Refractive index of glass, they are asking. So what is the formula? Speed of light in air divided by speed of light in glass. So the speed of light in air is 3 into 10 to the power 8 meter per second. Speed of light in glass given 2 into 10 to the power 8. So it will become 3 by 2. 3 by 2 is 1.5. And remember, refractive index is unitless, because here is also a speed, here is also a speed. So that is why this is unitless quantity. Third, okay, just all of you try to solve this third part by yourself. Just try and just tell me the answer. Okay. You can just tell the answer in terms of the fraction also. Just try this. Okay. I think before trying this question, uh, first take the screenshots of this. Okay, Matthew, Nawal, and Nafisa, please take the screenshot first. Then
Done.
done. Okay. Okay. So
Wait, sir, not yet.
okay, no problem. Fine. You have a time of 10
Yes, sir.
seconds. Just a minute, I'm coming. Scroll down.
Yes, sir.
Okay.
Yes, sir, done.
Done.
Yes, sir, done. Yes, sir, done.
Done.
And try this third part by yourself. You have to find the refractive index of glass with respect to water. Okay.
Size is 0.88. So is it 0.88?
0.88. Okay. And anyone else? Nafisa and Nawal? Very easy question. Okay. So answer number third. See, answer number third. We want to find the refractive index of glass with respect to water. And this can be written as refractive index of glass divided by refractive index of water. We have the refractive index of glass, that is 3.2, 3 divided by 2. And we have the refractive index of water. What is the refractive index of water? 4 divided by 3.
1.3.
Yeah, you can write in that way also, but I am writing in this way.
Oh,
Will be
okay.
better. Yeah, it is 3 divided by 2 multiplied by 3 divided by 4. So it will be 3
6
divided by
by
4.
9 by 8.
9 by 8. So the answer will be approximately 1 point something. So okay, now you can take the screenshot of this question. It is very easy question, but you have to understand the difference between the absolute and the relative refractive index. Okay, Nawal and Nafisa, have you understood now how to solve?
Yes.
So these types of question only you will get in your exam. Very simple questions. But you have to apply the mind. Next question. Again, this question is based on the relationship between the refractive index and the wavelength. How the relationship between the wavelength and the refractive index. So in this question, it is given that lambda A means the A is here for air, and D is here for diamond. D is here for diamond. So air is some different medium. Air is another medium. Diamond is another medium. So what they are saying and what they are asking, they are saying that the wavelength of light in air is this 4,800 angstrom. Angstrom is a unit to measure the very small length. 1 angstrom is equal to 10 to the power minus 10 meter. Very small unit. A refractive index of diamond is given. Refractive index of diamond is 2.4 given, and they are asking find the wavelength of light in diamond. Wavelength of light in diamond. First thing, it is given that refractive index of diamond, it is given as 2.4. Refractive index of diamond. If this refractive index is given, so basically we will say this refractive index will be with respect to air. Okay, with respect to air. Na? If nothing is given, you will consider refractive index of diamond with respect to air. That is equal to 2.4. So you can write here this value refractive index of diamond divided by refractive index of air is equal to 2.4. Now we have this relation. We have this relation. Oh, sorry. We have the relation refractive index of medium 2 divided by the refractive index of medium 1 is equal to velocity or speed of light in medium 1 divided by the speed of light in medium 2 is equal to wavelength of light in medium 1 divided by the wavelength of light in medium 2. So we will use this relation. Now here is mu2 by mu1, and here is refractive index of diamond divided by refractive index of air. So how you will write it? You will write it refractive index of diamond divided by the refractive index of air is equal to wavelength of light in air divided by wavelength of light in diamond is equal to 2.4. Is it or not? Now we will use this relation. Okay. So it is given that lambda A is given as 4800 angstrom, and lambda D we have to find, and it is 2.4. So lambda D will be equal to 4800 angstrom divided by 2.4. Okay, when you will remove this point, so here will be 10 and finally you will get the answer 2000 angstrom. 2000 angstrom. So, so with the help of this relation, you can just find this. Okay, so take the screenshot. We will move to the next topic.
Done.
Done? Okay. Just complete this, and after this, we will discuss the laws of refraction. Laws of
Yes, sir,
refraction.
done.
Okay. So laws, we have studied the laws of reflection. So two laws of reflection are there. Uh, we can say the angle of incidence is equal to the angle of reflection, and second is the incident ray, normal, reflected ray at the point of incidence are lying in the same plane. So for the laws of refraction, one law is common, that is the incident ray, refracted ray, normal at the point of incidence are lying on the same plane. But second law is different. We have there angle of incidence is equal to the angle of reflection. There is a relationship between the angle of incidence and the angle of reflection. But here we have different kind of relationship between the angle of incidence and the angle of refraction. Reflection and refraction, there are two different things. So laws of reflection. Okay, so this is the incident ray. Incident ray, and this is the refracted ray. Refracted ray, and this ray is traveling from one medium to another medium. Suppose this medium is medium 1 having the refractive index mu1. This is the another medium having the refractive index mu2, and this is the angle I is the angle of incidence, R is the angle of refraction. So R is the angle of refraction. First means the laws of reflection. Refraction is first is, you can say, the incident ray, normal, refracted ray lies in the same plane at the point of incidence. This is same as that of law of reflection. But the second law or another law, you can say, is given by Snell's law. This is also known as the Snell's law. So see, we will see what is the Snell's law.
Done.
Okay. This is medium
Sir,
1. This
sir, can you scroll up?
actually, okay. This is not finished. I was
All
waiting for
right.
the. Actually, I was waiting for the azan. Here is the
Oh,
azan
okay,
time.
okay.
Yeah, in Delhi there is azan time. So
Okay.
yeah.
Uh,
Uh, so I will give you the time for noting down. So basically, the Snell's law for the understanding of the Snell's law, what the Snell did. Uh, medium one. This is the medium one and medium two. Again, he have taken the same medium here, mu one and mu two, and again mu one, mu two. Again the mu one and mu two. This is medium one and medium two. Here, uh, the pair of media or pair of media is a plural of medium. So here the pair of medium is not changing. For example, this is air and water, this is also air and water, this is also air and water. But what is happening here, in first case, this is case first. In first case, the angle of incidence is I1 and angle of refraction is R1 for the same media. In the second case, the angle of incidence changes. Suppose this is the interface and this is the normal. Okay, this is the normal. First, the light ray is coming like this. Another time, the light ray is coming like this. Another time, the light ray is coming like this. So the angle of incidence of the light ray is changing. Accordingly, the angle of refraction is changing. So in this case, the angle of incidence is I2 and angle of refraction R2. But the medium, two mediums are same. Two mediums are same. Here also I3, R3 mediums are same. This is the case number second, you can say. And this is the case number third. Okay. We are not changing the medium here. Okay. We are not changing the medium. The pair of medium we are not changing, but the angle of incidence we are changing. And accordingly, we are getting different angle of refraction. Now there is he found that Snell's found that there is a relationship between the angle of incidence and the angle of refraction. So many means he have done experiments and all that, and finally he got the result that if you will just find out sine, you will take sine of angle of incidence. I1 means sine of I1 you will take and sine of R1 you will take. This will be equal to sine of I2 divided by sine of R2. This will also equal to sine of I3 divided by sine of R3. Means what is happening here? For a pair of medium, for a given pair of medium, the ratio of sine of angle of incidence and sine of angle of refraction is same. That is the Snell's law. Okay. Sine I divided by sine R is equal to constant, but this statement is very important. For a given pair of medium, for example, for air and water medium, the sine I by sine R will remain constant always. But for air and glass, the value will be changed. Sine I by sine R, the value of sine I by sine R will change. So this is known as the Snell's law. And you can say another law of refraction. So we will elaborate this. We will elaborate this law. Okay. This sine I by sine R is also equal to refractive index of medium 2 with respect to refractive index of medium. He found that sine I by sine R is equal to refractive index of medium 2 with respect to the refractive index of medium 1. So you can write it as mu2 divided by mu1. Mu2 divided by mu1. Okay. So we can write the Snell's law as refractive index of medium 1 multiplied by sine of angle with the normal, that is sine I, is equal to mu2 into sine of r. For solving the numerical, purely we will use this formula. If someone is saying what is Snell's law, then you will not say mu1 into sine I is equal to mu2. Snell's law is simply the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of medium. But this thing is for solving numericals. First we will see the refractive index of that medium, and sine of angle we will take. I will explain when we will solve numericals. For example, this is the numerical we want to solve here. Very easy question, but you have to understand. Okay, this is the incident ray and this is the refracted ray. So light is incident from air, and the light is going in another medium having the refractive index of √3, and the angle of incidence is 60 degree. We have to find this angle of refraction and angle of deviation also. Angle of deviation also. Okay. So we know that how you will apply the Snell's law. How you will apply the Snell's law. Start from any medium. You can start from the medium from which the light is coming, or you can start from the medium in which the light is going. For example, I am starting from the medium from where the light is coming, from this medium, and I am applying the Snell's law. Okay, mu1 into sine I1 is equal to mu2 into sine of r. This is not I1, this will be I, only I. Mu1 into sine I, mu2 into sine I. Now forward this mu1 into sine I and mu2 into sine I. See how we will apply. What we will do, first we will take the refractive index of the medium. First choose any medium. Suppose you have choose air medium. Okay, so we have choose first air. So what we will do, we will write the refractive index of that air medium. What is the refractive index of air medium? 1. And after that we will take the sine of angle with normal. So sine of angle with normal is sine 60 here, and this will be equal to refractive index in another medium, that is √3, and sine of angle with normal, that is sine r. So sine 60 is √3 divided by 2, and here is also √3, and here is sine r. √3 and √3 will be cancelled out, so you will have sine r is equal to 1 by 2. Sine r is equal to 1 by 2, and 1 by 2 is written as sine of 30 degree. So angle of refraction you will have 60 degree. Means this value you will have 60 degree. Okay, so this r value you will have 60 degree. Now here I am writing this is 60 degree. Now what is the angle of deviation? Suppose if there is no refraction of the light, in which direction the light will go? The light will go straight like this. The light will go straight like this, and this angle is known as the angle of deviation. This angle is known as the angle of deviation. Now there is one more mathematical concept. These are two vertically opposite angles. This angle and this angle are vertically opposite angle. So and what is this angle? This angle is del plus 30 degree. This angle is 30. So del is the angle of deviation plus 30 degree is equal to 60 degree. So angle of deviation is equal to 60 degree minus 30 degree. You will get the answer 30 degree. So angle of deviation I will represent with this type of del, and angle of refraction is R. We have to find both the values. So in this way you will apply the Snell's law. Okay. Okay, so there is one more question, and first just take the screenshots of this, then we will discuss the next question. Completed?
Yes.
Yes, sir.
Okay. Don't think this is R. Okay, this is not R. This is mu. Sometimes, okay, when I write with speed, so mu I write like this. So you have to remember this also. Okay. Just take the screenshot of this question. Okay, so
Yes,
scroll
Vidya.
down. Okay, just wait. Okay, now you can take the screenshot.
Sir.
Deviation means initially if there is no refraction, then the light will go straight like this. But where the light going? In here, this is the actual path of the light. This is not the actual path. So how much the light is deviated? This much the light is deviated. So this is the path of light, you can say. Okay, so already I have told you what are these things. Another question. In this question also, we will apply indirectly the Snell's law. So what is happening? This is medium 1, medium 2, and again here is one medium. So what you have to do here? They are asking to find this angle E. Okay, we have to find this angle E. So light is coming like this. This is the incident ray first. First the light ray is going medium 1 to medium 2. First the light ray is going from medium 1 to medium 2. Okay, no problem. So if this is the angle of incidence, and suppose this is the angle of refraction R, this is the angle of refraction R, let's suppose. So can we apply the Snell's law between medium 1 and 2? So you can write for medium 1 and medium 2. We can apply the Snell's law. How to apply the Snell's law? First choose the medium. This medium we have choose and write the refractive index of this medium, that is mu1, and multiply it with sine of angle with normal. This is the normal. What is the sine of angle with normal? Sine I. Now for another medium, medium 2, what is the refractive index? That is mu2, and sine of angle with normal is sine r. Okay. So from here, just find out mu1 by mu2 or mu2 by mu1, anything. So I am just finding out mu1 by mu2, and mu1 by mu2 is sine r divided by sine I am getting, and this is your equation number 1, suppose. Now apply the Snell's law for medium 2 to 1. From here the light is going up. Okay, first from the starting, first light is coming from medium 1 and entering to the medium 2. Now light is just coming from this medium 2 and just entering to the medium 1 again. So what you will do for medium 2 and 1, for 2 and 1, 2 and 1 means we are applying the Snell's law here at this interface. Okay. This is the normal, this is a plane, means this surface is parallel to, now mathematics, little bit geometry is used here, will be used. This is this line and this line, and you can say this surface is parallel to this surface, this interface is parallel to this interface, and this normal and this normal both are parallel. So if this is angle r, then again this angle will also be r. Again this angle will also be r. So now we can apply the Snell's law for this and this pair of medium. So how to apply? Here in this medium, write the refractive index of this medium, that is mu2, and write sine of angle with normal. Sine of angle with normal is sine r is equal to mu1. Here is mu1, and sine of angle with r, that is sine e. So just again find mu1 by mu2. Again find mu1 by mu2. So see what you will get. mu1 by mu2 you will get sine r divided by sine e. This is equation number 2. Now compare equation 1 and 2. Here is mu1 by mu2. Here is mu1 by mu2, means this left hand side of both the equation is equal. So right hand side of both the equation must be equal. So you can write compare 1 and 2. You will get sine of r divided by sine of I is equal to sine of r divided by sine of e. Okay, this now you can just say the sine r and sine e will sine r, and here is also sine r, here is also sine r. You can remove it. Okay, so finally what you will get? You will get sine e is equal to sine I. So what is E? E is equal to I. So the angle of E, this angle E is known as the angle of emergence. Okay, this is also known as the angle of emergence, but this angle E is equal to the angle I we have given. Okay, this value is given. Okay, so take the screenshot first.
Yes, sir, done.
Done.
Done, sir.
Okay. After this, we have completed. Okay. Real depth and apparent depth. What is an real depth and basically apparent depth is due to the refraction of the light. So what happens? Suppose this is a tank of tank. This tank contains the water, and surrounding it there is air. And this is any object at the bottom of the tank is placed. This is the object here. Okay. So see what will happen due to the refraction of the light. First of all, we will see actually na what will happen. You can just see this experiment by yourself. Okay, this object when you will see from here, when you will see from here, this is your eye. When you will see from here, this object will not be here. It will be somewhere here or here or here. Means laterally upward shifted. Okay, upward there will be the upward shifting. Okay, this object will not appear here to you. It will be appear to you at a height above this surface. And how? See how you will see that suppose D is the depth of this tank. Basically this is a tank, water containing tank. Okay, and from this object first ray is supposed like this, is normal to the surface, so it will go straight, no problem. Normal incident. This is the interface between the air. Here is the air and here is water. This is the interface. Okay. Another ray from this object, suppose like this. Now there will be the bending of light. Here the bending of light is not taking place because the light ray is normally incident. Okay. But here the light ray is going like this, and here will be the normal. Normal will be like this. Normal will be like this. This will be the normal. Okay. So now you can see here the light ray is going from denser to rarer medium. This is the normal. Light ray is going from denser to rarer medium. It will bend away from the normal. It will bend away from the normal like this. It will bend away from the normal. So final light ray will be like this. And when you will produce this light ray backward, here will be the image you will get here. So this object will appear to you here at this position. This is known as the apparent depth. Okay, this object, you will see this object here. From your eyes. This is the human eye or the eye of any other. So this distance is basically D dash. Okay, D dash. Okay, so now you can see D is the real depth and D dash is the apparent depth. And there is a formula to calculate the real depth and the apparent depth. So I am writing simply n2 by n1 is equal to d divided by t dash, that is equal to real depth divided by apparent depth. real depth divided by apparent depth. Apparent depth. What is the meaning of the apparent depth? You are just, this object is appearing to us here, but in actual this object is here. This object is appearing to us here due to the refraction of the light. And N2 is the refractive index of the medium from which the light is coming. So N2 is the refractive index of the water here. N1. Okay. So just take the screenshot, and rest of the topics we will discuss in the next class. Okay. So don't confuse here. Just wait a minute. Just wait. Okay. Remember this formula. This is very important formula. Now you can take the screenshot. And remember, this position is the apparent position. This is D dash. Okay, this is D dash. This is the apparent position of the object. In actual, the object is here, but due to the refraction of the light, the object is appeared here. Completed?
Yes, sir.
Okay, and remember, D and D dash I have measured from the, you can see, measured always from the surface. So this is the surface. Okay, measured from here, measured from the surface. So this is the surface.